You don't necessarily have to write it down unless you want to, but again, we have the data all shown for us. We have the relative frequencies already calculated. You just have to now tell me in words what that means in the situation. So table 4, you'll start us out. What does that 10% mean in context of the situation? You want to answer my question, Brayden? Or okay, well, don't ask me. We talked about this at the beginning of the year. Do not interrupt me to ask me directly. That is not an appropriate. So table 4. What is that 10% mean? 10% of what? So 10% of people that prefer cake and are left-handed. I would actually change that just a little bit. I would say 10% of people that prefer cake are left-handed versus and. Because then when you put that and in there, that kind of implies out of everyone's survey, but that's not. It's 10% of only the people that prefer cake. So class, how many people prefer cake? No, not the percent. How many people? So that is why we divided out of 100, right? Whatever follows the word of is usually your denominator. We're not saying of the people surveyed, not of the 300. We're saying of only the people that prefer cake. And the 10, that is my numerator. Those are the ones that are left-handed out of those people. Okay? Because if we were doing it out of 300, the percentage would be way different, right? So you have to be very clear. So anything that follows the word of, given that among those who blah, 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 that should always be your denominator. Questions on that? Okay. So good. Table 5, what about the 67%? What does that represent? Okay. So the way that you said that kind of implies that we're dividing by the total survey. But really, it's 67% of what people? The amount of people that are right-handed. So that's how you rephrase that. We're not just saying that 67% of the people surveyed are right-handed or and prefer pie. We're saying 67% of the right-handed people prefer pie. And you might be thinking that's the same thing I said. It's not. Okay. You need to have something that tells me the 270 is the denominator rather than the 300. By the way, as we learned yesterday that the hard part with the relative frequencies is knowing what to divide. These boxes in the more center part of your table, the ones that have the 2 characteristics at once, these should never be your numerators. Or sorry, these should never be your denominators. What you're dividing out of should be a total of some sort. Whether it's just one category, like these totals up here, whether it's the columns, or whether it's the total survey. But your denominator should never be like the ones that are the 2 characteristics or so all right, last one, table 6. 30% represents what in the situation? Okay, good. 30% of those surveyed. That one is out of 300. So that's out of everyone. And then you still mention the other two characteristics. You say that, because it's the 90, you say 30% of those surveyed are right-handed and prefer faith. So you're still mentioning both characteristics in each, but the way you phrase it depends what you are dividing by. Your denominator should be following a phrase similar to of, out of these people. All right, questions on that? All right. Again, that's not on your paper. That's just something we are practicing because relative frequencies can be hard. But it's mostly like the English language of it. So it's almost like an English lesson, like saying this means that, not the other way around. We're still going to continue looking at categorical variables, and we're going to look for relationships between them. We're going to see if based on the relative frequencies, we can say that there's an association between two variables. So we didn't necessarily calculate all the relative frequencies for the warm-up, but look at the two things being compared. Whether someone's left or right-handed, and then what dessert they prefer. Without looking at the numbers, like, do you think that there's a relationship between those? Does you being right-handed mean you like a certain dessert better? So like logically, we know like there's probably no relationship between those. But if we calculate some values and see that there's a certain trend, like, I don't know, maybe only right-handed people like pie. I don't know. It's like a staggering amount. We could say that there's an association, a trend, but that doesn't necessarily mean that there's like a cause there. You being right-handed doesn't cause you to like a certain dessert, but you can still say that there's an association. So we'll be looking at that today on the front side. It's like a tumble lesson. So the front, we'll just be talking about associations. On the back, we are going to start estimating linear models. So describing rate of change and y-intercepts, and drawing a linear model that fits the data well so that we could use it to estimate other values. I'm recording right now. I record all the time. The practice, because it's a combo lesson, are separate, but they're both very short. So make sure more than ever, this is a really short unit, that you are staying on top of your work. And side note, the work from the last unit was due last Tuesday. I have people rushing me to grade in the work that's from that unit that they turned in last night. And like, I don't need to grade it at all. It was due before the unit test. After the unit test, it really doesn't matter for your grade. Okay, so if you want to take several weeks to turn in one assignment, you can give me like a 1 week to grade it. Really good. You know, you just need messing me. I'm not going to drop everything I'm doing to grade your weight homework from last unit that is way past due. Okay, stay on top of it. The only reason sometimes I don't disable them right away is because some people do get extra time. Not all of you. So keep that in mind. Last reminder for your minor check. That should be 100% for everyone. If it's not, like that's really on you. If you do the math, you need to take notes in order to pass. If you take no notes or you lose all your notes constantly, the highest grade you could get is a B, and that's if you get 100% in everything else. That you never get a homework question wrong, that you never get a test question wrong. So really, realistically, if your minor checks are bad, then the highest grade you can get is. So keep that in mind. That's supposed to be a nice cushion for your grade, but still. And I do like to update you on the stats for your tests after the retake. They really are. I don't have it for the constructive response yet, because again, I'm allowed a full 7 days to grade your work, so I'm going to take my time. But the online portion was already updated for everyone. So, see how you did? There was an improvement in all of my classes, but I would say this time around, maybe only half of the class did better the second time around. If that continues to happen, like you're not improving on these planned retakes, like we don't need to read them in class. You could come after school and just take tests to do better on that. That way we're not wasting time in here. Be prepared for the retakes. You should all be doing better on the retake than the first. All right, but anything further, if you are still failing, even after all these retakes I give you, then you need to come to tutoring or you will probably fail the class. The same. Go to Saturday Academy, ask to do corrections, ask for help. But typically I have really good grade distribution. So if you're failing, like you need to do more than what you're doing right now. All right, but enough lecturing. We have a quiz this Friday. We'll have one quiz this evening. And then the Friday after that, you'll be testing. Really short. Questions, comments, concerns? Side note, I do have tutoring today. I do not have tutoring this Friday. I messaged about that. So if you are planning on getting tutoring for me this week, you have to stay. All right, now to what's actually on your paper. We are going to see if there's associations between some variables, and it's kind of like science class. Think of it like science class. The two-way table displays data about 55 different locations. Scientists have a list of possible chemicals that may influence the health of the coral. We first look at how nitrate concentration might be related to coral health. This table displays the health of the coral, healthy or unhealthy, and the nitrate concentration, low or high. You don't need to know what coral is. You don't need to know what nitrate is. All you need to know is that this is where it's low, this is where it's high, this is where it's healthy, this is where it's unhealthy. We're going to try to see if there's trends in the data. To do that, you are going to make a relative frequency table, but you always have to pay attention to how they want it, because it won't always be divided by your current. So for this one, they want you to do it based on the total for each column. Do you guys know the difference between column and row? Columns go which way? Okay, good, up and down. And you'll notice the reason why this is 100% is because in this one they did 28 divided by 28, because that was my column total. Here's my total for that column. Over here, they had to do 27 divided by 27 if it's going to equal 100%. So make sure you do it based on its column total, whatever you get for these marks. And notice it has it as percents. So you should make these percents to keep it consistent. Then answer the rest of the questions, which had a higher relative frequency, blah, blah, blah. Answer those questions, and then we'll see if there's an association in the data. Table 7, what's the relative frequency for the low nitrate concentration of the healthy coral? 71.4%. And what did you divide to get that? Okay. So relative frequency, whenever it asks for a relative frequency, what should your answer be? A decimal or percent. It just depends how it's formatted in your answers. In this one, it wants a percent because it shows it out of 100% right here. So I should keep it consistent. The hard part is just knowing what to divide. And it said to do it by your column total. So take note from here. If this was 100%, they had to have divided it by 28, not by the 55. And then the value that was here on the table given to you was 20. So yes, that does work out. 20 divided by 28 gives you a long decimal. Times it by 100% to make it a percent. Also, make sure you guys know how to round. So I like roughly remember the answers. I'm going to check all of them for you. But where people are getting wrong is they don't know their rounding rules. All right, but that one is rounded correctly. So good. Table 8. Give me the relative frequency for the unhealthy low nitrate concentration. All right, and it didn't say what to round to, so we're just gonna keep it consistent. It looks like table 7 rounded to 1 decimal, so we're gonna do that for this one. What did you divide to make that happen? 8/10. All right, good, because again, we're doing it by the column totals. We're seeing what ratio of our low nitrate concentration locations had healthy versus unhealthy coral. When I put that in my calculator, it gives me a long decimal. When I times it by 100% and round to the nearest tenth, it should be 28.6%. So off by 0.1. Here's what the decimal looks like before I timed it by 100%. Here's what it looks like after I timed it by 100%. Wherever you are rounding to, underline it and look to the right of that number. Since that number is between 5 through 9, I do need to round up 1. I wouldn't want you guys to get it wrong just because of rounding. Like, you know what to do, got it right, but you just round it wrong. Okay? Questions on that? Yes? Yeah, it didn't specify in this one, so as long as you kept it consistent and rounded all of them to the nearest whole percent, then that's fine. All right, good question. Other question? Just read carefully. I think I saw on your homework, it's specified on some of them, so if you don't follow those directions, it'll mark it wrong. All right, table 9. What about for the high nitrate concentration of healthy coral? 18.5%. And what did you divide to make that happen? And what was the numerator? All right. So then don't divide it by 28 because this one has a different column total. And then times by 100% and rounded, that is correct. Table 1. What about what's missing here? What percent should go here? 80.5%. What did you divide to make that happen? 2. All right, so just gonna make sure that we're rounding right. It's all I'm checking for. And I got 81.5, which would make more sense because then it would add to 100%. Because we remember, like, these should add up to this total. Okay? Questions on that? And normally we wouldn't put the fractions, but I think for notes it's good so that when we look at it later, you know how we got those. But yeah, now that was actually like yesterday's skill. Today's skill is seeing if there's an association or not, if there's a trend. So we're going to answer these questions. Table 2, you're going to answer it. When there is a low nitrate concentration, which had a higher relative frequency, healthy or unhealthy coral? Healthy. You know, from looking at this column for one, and then yes, the healthy is higher. Good. Everyone know where to look. Everyone table. Good. Table 3, you'll answer the next one. When there's a high nitrate concentration, is there a higher relative frequency of healthy or unhealthy? Unhealthy. Looking at the correct column, seeing that the unhealthy is higher. Because although you could probably tell me which is higher based on the first table they gave us, this gives us out of a whole. Isn't 81% pretty significant? Yeah. What about 71%? That pretty significant? They're definitely not close to each other. It's not like 50-50. So decide if there is an association. Talk about it briefly. Ms. Medina. Okay. So based on this data, is there a possible association, relationship, trend between the coral health and the level of nitrate concentration? Raise your hand if you think yes, if there's an association. Raise your hand if you think no. Okay, so out of the handful of people that voted, at least we voted right. Yeah, if it's more of a significant split, then yes, there's probably an association, a trend. Even if the variables don't necessarily make sense together, we could still say that there's an association based on the numbers. Okay, so you would say yes, and maybe you could mention the trend. And there's a few ways you can mention it. You could say yes, because as the nitrate increases, what happens to the healthy coral? The healthy coral decreases, or something like that. You could say the unhealthy coral increases. Few ways you could say that, but it is a pretty significant amount, 80%, 75%, those are pretty significant. Okay, good questions so far. Now, scientists next look at how silicon dioxide, so a different chemical, might be related to coral health. The relative frequencies based on the total for each column are shown in this table. Based on this data, is there a possible association between coral health and the level of silicon dioxide concentration? So they're not making you calculate it, they're just giving it to you this time. Looking at this data, don't say it yet, just talk of your groups when I say it. Is there an association between the silicon dioxide and the health of the coral? Talking your groups, yes, no, why? Okay, so class, all at once. Is there an association? Yes or no? And why not? Is there a significant change when there's low versus high levels of that chemical? No. So, and also, these are pretty close to each other. It's like a 50-50 split almost. So you could say a few different things to justify it, but you could say no because the health doesn't change much with different levels of the chemical. So you'd say there's probably no association, no trend, maybe no relationship between that chemical and the coral, because the data doesn't change much when there's different levels of it. Also, and you'll see on your practice, if it's like a 50-50 split, there's probably no association there. All right, questions on that? There is one more activity on there, but I think you guys get the point. Hopefully you can tell if there's a trend or not based on the relative frequencies and the numbers in general. We're going to go to the backside now, where it talks about linear models. So generally when we look at trends, so like, yes, you can look at relative frequencies from two-way tables, but generally when we look at trends, we mostly can see them from a scatter plot. In college, every single lab class that I had, so if you're planning on going into like a STEM field, anything medical, anything like science or engineering related, we'll take a whole bunch of lab classes. And in every single one of those classes, it was us gathering data, putting it in a graph, putting a trend line on it, and looking at the statistics and answering questions with our statistics. So this is really similar if you plan to go that route. We're going to kind of do an experiment, if you will. I'm going to play a video and you're going to record the weight for the number of oranges that are being put in a box. All right, so you're collecting the data, so to speak. Let me pull up that video. Okay. So how many oranges are in that box? 3. So you see on your table to fill out where it says 3 oranges. What's the weight in kilograms? I know it's hard to see if you're in the back, sorry. But what does that scale say? 1.027. And then as they keep adding more and that scale settles, you're going to write that value. Hopefully if you miss one, that your table, hopefully you're all right. Okay, but I'm gonna play, I'll try to pause it, but you know, kind of got to keep track too. So that's our 3 oranges. Here's 4. Sorry, tried to pause it, couldn't. So that's 6 oranges. Now there's 7. Now there's 8. Nine oranges. And 10 oranges. Okay, I'll go back to where I couldn't really pause it for you. So if you missed any, come get it now from this video. It's playing again. So here's the 4 oranges. Five. 6, and then I think you got the rest, but I'll let it play in case you didn't. 7. 8. 9. And 10. Okay, so you should have filled this out. Talk in your group. If you missed one, maybe they have it. What you're going to do with this data is create a scatter plot. So scatter plots are not like connect the dots or anything. You're just plotting your points. So in your table and your scatter plot, the X's are your number of oranges because that's on your X axis. The Y's are your weight in kilograms. Whatever you put in this table is going to be like an XY coordinate. So you're making a scatter plot. I know there's no grid lines, so just do your best based on our data. I'm going to freeze my screen and do it while you're doing it. All right, so I just finished my scatter plot. So number 2 just had you creating a scatter plot of your data. This was our data. And the axes were already labeled for us. Oranges is our X. The weight in kilograms is our Y. So each of these are coordinates. And scatter plots are just you plotting them. They're not like connect the dots. It's just a bunch of dots further out. All right. Can you see a possible trend in the data? Like, can you tell if it's going up from left to right, down from left to right, or is there no relationship? You can clearly see that as the number of oranges increases, so does the weight, which makes sense, right? Like there's no way the weight would decrease if I'm adding more into it. But yeah, scatter plots help us see those associations maybe a bit better than some of our relative frequencies. But that's our scatter plot. We are going to make a linear model by drawing a line through the data that fits the data well. So that you'll be tested on as well, making a scatter plot and drawing what we call a line of best fit. So maybe take down some notes. If it fits the data well, then the line you're drawing goes through the middle of the data where the points are clustered around it. Because we're creating a linear model. When you hear the word linear, what should you be thinking of? Straight lines. So you're gonna do your best. If you have a ruler, I mean, I don't think it's really common for people to have rulers right now, but a ruler, something like another piece of paper, line up to where you are creating a line. And I don't like that line. You want to create a line that looks like it's going through the middle of your data where the points seem to be clustered around it. Like you don't want all of them to be above it. You want all of them to be below it. You want it to go through the middle of your data where the points seem to be clustered around it. Best you can. So does it have to touch all the dots? Does it have to touch any of the dots? Technically, no. It just has to go through the middle of the data. If it touches some of the dots, great. But we need like some above, some below. So that's a point seam clustered around it. That will be some points. It's just you knowing where to draw the line. Middle of the data or the points are clustered around it. Now we are going to, because this is a linear model, we're going to estimate slope and then we're going to estimate the y-intercept. What formula are straight lines? Don't be shy, what is it? Y equals mx plus b. So it's a straight line. We're going to estimate the slope in number 4 and the y-intercept in number 5. Typically, only the m and b are replaced with numbers. Now, to calculate the slope, yeah, you guys typically do rise over run. Doesn't always necessarily work when the tick marks are like this. So I'm going to give you a different formula for slope when it's coordinates. So write it down under number 4. For the slope, when we're doing these exercises, I recommend y2 minus y1 over x2 minus x1. It is equivalent to rise over run or change in y divided by change in x, but this one does work better for this unit and also moving forward. What's another word for slope? Rate of change. So in unit 4, you're going to learn about average rate of change, and it's going to be the same formula. That's what slope is. Now, for this formula, I need 2 coordinates that appear to be on the line. It does not have to be a data point. If it is a data point, then it must be like perfectly centered on the line. We do happen to have a couple. In the one I drew first hour, we didn't have any. So there can be like some variation, but you want to pick parts of the graph that you don't have to estimate a whole lot. So like, for example, if I had grid lines, that'd probably be preferred. But right here, that is from the line. It's the coordinate 3, 1. And I don't really have to estimate it. So I'm going to pick that one as one of my 2 coordinates that I need. You yourself come up with a few others. I'm going to call in some groups because there should be multiple parts that you don't have to estimate. So come up with a few. I'm going to call in you shortly. What are some parts of the line that I can tell without having to estimate a whole lot? Like a moment to look for it. Everyone else think of like a few others. Okay. 8 and what value did you estimate this to be? Okay, my 2.5 is like way up here. It's possible, like, because we all don't draw the exact same lines. Like, it's possible your line might go way up there, but then I would think that that's too far above our data. Does that make sense? So on mine, if I'm doing 8 for the x, kind of looks like it's between just under the 2. So in between the 1.75 and the 2. So I'm not loving that point because I'm having to estimate it a little too much. Let's see. See if I can find a different one. So aligning it with this 2 on the Y and then looking down here, it looks a bit like right in the middle of the 7 and 8. So I'm a little more comfortable estimating that one. The X being 7.5 and the Y being 2. So we want it to be on the line and that we're not having to like estimate too much. Does that make sense? Maybe. Okay, anyone, I need a volunteer because I don't want this to take too long. I need other points that we could see. Fulton? 9 and 2.25. Okay. Yep, I'd say that's pretty good. And one more, just so we could show that there's multiple points to pick from. Maybe any down here that are not that hard to estimate and they're a little easier to see. What point is that approximately? What X value? Okay, it's what Y value? 0.75, yeah. So in summary, you really only need 2 points. I'm showing you that there's more. You need to pick 2 points from the line to estimate your slope. We found 4. You can pick any 2 that you want. I'm gonna pick this one and that one, because why not? They just have to be on the line. Now, in order to use this formula, just make one of them x1, y1, and the other x2, y2. So if I'm labeling it this way and plugging it into my formula, my y2 is 1, my y1 is 2, my x2 is 3, and my x1 is 7.5. So class with 1 minus 2. -1, what is 3 minus 7.5? -4.5. Put that in your calculator. -1 divided by -4.5 is about 0.2 repeating, and it's positive. So this is me estimating my slope. When I do write my linear model, it's going to be 0.2 for the slope, and then now I just need to estimate my y-intercept. If you can see your y-intercept on your graph, because sometimes you can't, sometimes it's like off the graph. If you can see it on your graph, just pick it. What is my y-intercept? 0.5. And then putting it together as a linear model, this is me estimating my linear model. That's my slope and my y-intercept. In first hour, when we estimated the slope, we used different coordinates and we got 0.17. Wouldn't you say that 0.17 is close to 0.2? Yes, it's very close. So depending on what points you pick, we're not all going to have the same answers. In fact, if you take your test and you have the same exact answer as the person next to you, I'm going to be pretty suspicious because like the odds of that happening kind of low. When I do grade it, I just check to see, are your answers close to my answer? I don't expect them to be the exact same as mine. We need to estimate your All right, so really important skill, don't lose your notes, we're gonna pick it up here tomorrow. Hopefully it's making sense. I mean, one person responded to you and I asked why intercepts, like that's really elementary skill. If we're not losing those foundational things that we also talked about this year.